Hi, and welcome to Workshop 7, Working with Multiple Groups. In this demo, I'm going to be talking about demos 18 and 23. Now, Mplus has unique features to support the testing of hypotheses regarding multiple groups. So I'm going to be illustrating that through starting with some pretty simple examples and then going to some more complex examples. The problem with Mplus is that the default parameters are tricky. Sometimes you need to analyze the model parameters and know how to calculate the degrees of freedom yourself in order to make sure you're estimating the model the way you want. So in this module, we're going to do a simple regression to start with. We're going to be using the HSV2 data set that we used before, high school and beyond. And this is just an excerpt from it. And some of the examples, more or less, are examples similar to the one that you would find at this link. Now here are the variables that we're going to be looking at, and we're going to want to look at a mediation model where we are looking at reading, math, science, and social studies scores, all of which are continuous. And we're going to want to know if this mediation model varies by gender. So we're going to set that up. And to do that, there are two different ways we can look at it. We can estimate the effect of multiple groups using a group variable in the model command. And so here is the example. This is demo 18 case 2. We're looking at reading on math gender and math gender, where we made this interaction term. And then we look at reading on social studies and then social studies on math. So we have this model, or we can use the grouping command. So in the grouping command, this is then we'll be showing in demo 23 case 2, you read in your variables, and then you have this command here where you identify groups that you want Mplus to analyze separately. So you're telling it grouping equals, okay, use the variable called gender. And when the value is 1, we're going to call it female, and when the value is 0, we're going to call it male. So then you can use your model statement and define your model, which we will do, and that will be for the first or the reference group, which in this case is male, which is the 0 group. And so everything here that you define for your model in your model statement will apply to the male group, and then if you change it in any way here, that will apply to the female group. And then you can look at the model fit and make some determinations. So those are the two ways. It may not be completely clear to you at this point, so let me go through some examples. So to start off, in demo 18, we are going to be looking at a mediation model where we're looking at the effect of X, which is math, and the scores and how they affect reading scores. And is that mediated through the social studies score? So we talked about this before. Here you can see, I'm not going to go through this in any detail, what the equations are. A is the direct effect, B is the indirect effect, and C prime is the direct effect of X on Y. So here is our Mplus syntax. And if you see, we have a title and a data statement where we are reading in our HSV2 data. We have the names of the variables and the use variable statement as well. So we're only here looking at math and reading and social studies. We're doing an estimator equals ML bootstrap because mediation, we want to use a bootstrap procedure to get good confidence intervals for our indirect effects. Okay, so these are our model statements. We're looking at reading on math and social studies on math. All right, so we're going to kind of ignore the rest of this. So I'm running it, and we see that we have reading on math and social studies on math. So that's all good. And we look at the model fit, and it is a saturated model, so not too interesting there. So now I'm going to look at the similar model, but this is the moderated mediation. So does the mediation vary by gender? And here I'm defining a new term, which is the interaction term math underscore gen, which is the product of gender times math. And I'm including that in my model statement. Everything else is pretty much the same. And when I run that, now I see that both gender and math interaction term math underscore gender are, neither one of those are significant. So what the answer from this analysis appears to be that no, that mediation model is not moderated by gender, or the effect of the mediation, social studies as a mediator of math on reading, is not moderated by gender. Now I'd like to look at this using this new method that I mentioned, using the grouping variable. All right, so we just did demo 18 and we did case 1, and now we're going to do case 2. I'm sorry, that's not true. We did case 1 and 2. Now we're going to do demo 23, case 1. And that is similar to the original mediation, but is the effect of math ability on reading mediated by social studies. Only this time we're going to use the grouping variable. The same model is used for each group. Each group is run separately, but estimates are constrained to be equal. And that's the final statement, but I'm going to open up the INP file and move this over. There we go. So in this case, I have defined a grouping variable. So gender is my grouping variable. 1 equals female, 0 equals male. I'm actually going to take the bootstrap off there. It's only for convenience while we're running these models. There's no other reason for it. All right, so here are our model statements. As you can see, the first model statement shows reading on social studies, reading on math, social studies on math. And I've got a bunch of other stuff here too. Lots of things to talk about. All right, so first one is I'm using an index in parentheses, just so identifying a variable in some way to say, if I'm interested in that path, I can call it B1. The reason I need that is because I want to make sure the reading on social studies for the female model is exactly the same. So that way I know that they're going to be, each model is going to be run separately, but they're going to be run in such a way that the path or the regression of reading on social studies is exactly the same. Then I have reading on math. I'm doing that the same. I'm putting that so it's C1, and then social studies on math A1. I also want the intercepts to be the same. So I have those as B1, B0, and A0. And I want, these are the residual variances. So if you only say, you refer to just the variable with nothing else. So when you put something in brackets, you're referring to the intercept. When you put something after an on statement, it's the regression coefficient. And just by itself, it refers to the residual variance. So we see, based on how I've written this out, all of these should be exactly equal. So I'm going to run this. So the reason I want that is because I don't want to have separate models right now for both. So if you look through here, I'm going to point out a few things real quickly. This is for the male group. That's the reference group. Reading on social studies and math, 354, 504. And then for female, 354, 504. Social studies on math, 624, 624. The intercepts are the same and the residual variance is the same. So this is a model of the mediation where you're including your two groups, but you're not actually modeling them differently. You're modeling them and you want them to have exactly the same estimates. All right, fine. So that does this model fit well? Okay, we can look here. And we see that it looks like it does fit well. It has a p-value less than 0.05. Okay, so now I want to check to see what would happen if I want to test for moderation. So this is case 2. This time the estimates of the slopes are freely estimated for each group. All right, so how do I do that? I'm actually going to change this so these are not the same. There's all kinds of different ways to do it. If you want to be sure, I recommend doing it this way, but there are other ways to do it. So here your path is different. This one's B1 and this is female B1. This is C1 and this is female C1. This is A1, this is female C1. I am going to constrain the intercepts to be to equality. So I am not having them separate. All kinds of different ways to do it. You have to think about your theory to see if you think it's different. I have no reason to think that males have a different intercept than the females. And then finally, I'm also constraining the residual variances to equality. All right, there's a lot of other stuff in here that were leftovers from before, but we're not going to worry about that. I'm going to run it and get here. And I can see that I have this model where the paths coefficients are different for male and female, but the other values are the same. The intercepts are the same and the residual variances are the same. And the mediation is significant. The mediation regression coefficients are significantly different from 0. So it looks like a good model, but how do I tell? Well, the way we're going to tell is using our technique from before of comparing model fit. So I'm going to look at the chi-square test of model fit for the particular model that we're using, which gives us the value in the degrees of freedom and the p-value right here. Actually, I'm just interested in the value and the degrees of freedom. I'm going to take it from this one, which is case 2, and compare it to case 1. And there is a spreadsheet on model fit in the packet of files, the folder of files that's on Canvas. So here I have opened up the Workshop 7 Model Fit Comparison. And this is the calculation for case 23. So I would compare the mediation model to the moderated mediation model. Here's the here's the chi-square and the degrees of freedom, the chi-square and the degrees of freedom. So the way that we do this calculation is we take the difference, and you can see that this is the difference in the chi-squares and the difference in the degrees of freedom, and then calculate a chi-square for that. We now see that that chi-square is significant. It's not significant. So the change is not significant, meaning the moderated mediation model is not a better fit compared to the mediation model. And when the change is not significant, we prefer the simpler model. How can we tell which one is simpler? It has more degrees of freedom. So there are fewer parameters. So that's the simpler model, and I'm going to have this little comment on every model this time. So therefore, this aligns with the findings from the technique using interaction term. That showed that gender is not a significant predictor as a moderator. And this method shows that gender does not result, using gender as a grouping variable does not result in a better fitting model. So this is kind of the idea behind using the grouping variable. You might have a use for this in a regression model sometimes. So I just wanted to start with this because it's starting from a place that you were familiar. And in the next set of models, we're going to look at a more complex model with measurement and a path model.